Hey everyone, how are we doing? Got the volume up, got everything ready to go, got the Kahoot code in the background. We're good to go. Good to see you, Hannah, Zoe, Molly, Emily, Dee, Ella, Emma. Who else do we have? Andrew, good to see you. Emily, Meredith, Kirsten, Leah, Hannah, Maggie, Ben, Jensen, Kennedy, Abigail, Hannah, Tori, Caitlin, Daria, Elizabeth, Jensen. I'm saying multiple names twice, but good to see everyone. Good to see you, Audrey. I see other people are saying hey in the chat saying, yo, Michaela says, hi, y'all. Good to see you here. Leslie, good to see you. Got the code right up there, ready to go. Code is good to go. Good to see you, Sam. Everyone's checking their points. We had like 59 people watching last I saw. Let's get past 100. I reached 83 people watching. Yeah. That's awesome. Everyone join in. Lindsay, good to see you. Brian, hi. Feel free to say hi. Tag someone else in chat. I got some root beer tonight. There's some root beer. Good stuff. Good to go. Walter says hi. Carly says hi. Barrett says hi. Good. Or he says points. Barrett's checking out those points. Oh, let's throw some points out to the chat. Let's, Barrett, we need to fix that. There's 100 points right there, Barrett. Everyone's saying hey. Say hey to someone in the chat. Tag someone in the chat. Makes, it's really nice when you get into a chat room like this. You say hey to people. So that's what I always try to do at the start of these is I'm like, hey, everyone, how you doing? Because, just say, hey, good to see you here, Kiana. Good to see you, Adriana. Everyone's checking points. Everyone's like, how many points? Can we break 100? We're going to wait for let's put on a 2-minute timer right now. We'll see how many people we have. I've been updating the Kahoot. I updated and checked the Kahoot. Oh, I want to look at one question in the background. There was one question, which I think might have had a wrong answer. So I'm going to go look at the question really quick and double check it. It's a true false. And I looked at it and I was like, what? Did I write this? Let's see. I need to find it. It's about confidence intervals. Let me control F. We're at 84 people. Did I totally change the question? What? Wait. Increasing the sample size. Oh my gosh, I do think I... Yeah, that's right. Increasing the sample size will make the margin of error smaller. Not saying a question that's on the Kahoot. Not reading aloud questions on the Kahoot that increasing the sample size will make the margin of error smaller. I have no idea what's going on right there. Good to see you here, Walter. We got Walter and Walker. I'm really nervous because I've been focusing on my chem exam tomorrow. I've been kind of neglecting stats. No worries. And people want to meet up study, have a good time. 2-minute timer's almost up right here. We're going to start in probably just about 1 minute, so make sure to be logging in. The Kahoot link is up there. Make sure to go to kahoot.it. So Brandon, all the stuff is on the screen right there. So it should be all right there. Does everyone see it? We'll make sure Brandon's in. We've almost got 100 people. I love that. I love when we have 100 people. And there are questions on this that are on the test. Not lying. Just like straight up, it's really hard to write like 50 versions of a question. You're like, and there's only so many ways to ask what the sample size does to a confidence interval. It makes it smaller. It makes the margin of error smaller. So there's only so many ways to ask a question like that. So definitely pay attention to the questions, write them down, rewatch the Kahoot. We did some speed runs earlier today. Here's some advice for the speed runs. There's the timer. We'll start here in 30 seconds. 30 seconds till start. With the speed runs, do realize they're very quick. I want to drop this in the chat while we're talking right here. My favorite section of videos. We got 120 people watching. That's awesome. Sunday night, 120 people watching. Let me put this link in the chat. So if you're watching this right now, check out this link, and we should be starting here in a second. I'm gonna put this mega link in the chat. Where is it at? Never heard this song before. The link is, as the timer goes, this has pretty much every really awesome review video. It doesn't have the current ones, but if you take a look at this link right here, review videos, this is a really good review list. Thank you so much, Kaylin. I'm glad they helped. I've been a lot of work, so I hope if I seem burnt out, I'm sorry. I think we're all feeling it. Please help each other, support each other through these tough times. And if you know someone in need, 974 help. So I don't think it's a bad thing to talk about things like mental illness and sometimes depression. Please reach out if you're in need of help, and please help other vols who are in need of help. That's the last bit of advice I want to put out there on that. I heard some bad news. And so please, 974 help, and please help those you think need help. Like, try to be helpful to our Vol community. With that, let's be positive with each other. Let's help each other out. Vols help Vols. We know what we're talking about right here. Vol means all. Vols help all. You got it right there. That's my favorite thing right there, Michaela, is Vols help Vols. Vol means all. Vols help all. Thank you so much, Jensen. We're here for positivity. We're here to have fun. You know what we're here to do? We're here to win a Kahoot. Who's ready? I need some I'm readies in the chat. You know that's how it goes. I need some I'm readies in the chat. I'm readies. I'm going to take the last little bit of my drink right here. It's Barg's root beer, and it's good stuff. I need some I'm readies in the chat. Oh, Caitlin, you are awesome. We got I'm readies all in the chat. We're ready. Here we go. 3, 2, 1. Let's Kahoot. Got to go to the main screen. Okay, let's hope I wrote all the right answers. Here we go. The test uses a sample size of 98, hint, a standard deviation of 2 and a mean of 3. Find the degrees of freedom. What are the degrees of freedom? What are the degrees of freedom? So the test uses a sample size of 98. This is a one sample t-test. Hint, one sample t-test. The blooping is different noise on that. It's a one sample t-test. Who wants to put in the chat the formula for the degrees of freedom? Can you remember the formula? Oh, I hope everyone got it. It's a one sample t-test. Great job, Caitlin, right there. It's n-1, which is the sample size minus 1. The big thing to identify this for this problem was the sample size. Amazing work, everyone in the chat right there. What we have right here, I'm going to do one thing just in case, and it's for a very public video. I'm going to go, and I'm just going to do this really, really quick right here. Let's take a look at the leaderboard right here. Remember, the sample size for a one sample t, we can figure out the degrees of freedom. I'm going to do one thing just in case, because I'm going to go here. I should be able to go to this. Ooh, let's hope nothing crazy happens. Everyone cross your fingers. I'm going to the live studio room. I'm always afraid doing this. Live control room. Awesome. Everything. I didn't break the internet yet, have I? Okay, let me go here. There's a way to do this. Oh, wait. Oh, my gosh. What am I doing? Okay, there should be... Wait. I swear there was a way of doing it. I was going to put on the slow mode chat. Just in case. Just in case. Everything good. We'll figure it out. Okay. So let's continue on. I swear I found it. We haven't had to use it much. We're good, though. We're good. With this right here, we see Green Ostrich in the lead, Focused Dolphin also up there, and Bright Dog doing a great job. Excellent work. My gosh, look at these times. These are amazing right here. The click-through rate that people had on this, great job. So get ready. Let's see who's going to win with the next question. And please ask questions if you have it during these. This was a one sample t, n-1. So let's do the next question. Here we go. Maggie asks, how do you know it's a one sample t? That's when we're testing one mean. So one sample t is like when we're collecting data on students' GPAs. That's a quantitative question. So Maggie, it's a one sample t when we have one quantitative variable that we're talking about right here. And that would mean we have like a histogram. So here, let's show that really quick. We've got the all graphic screen that we always refer to when we're looking at the one sample t. 2 seconds. So all graphics right here. There we go. So when you have quantitative variables, you have like a histogram up there. And that's going to be when you're looking at one mean. So make sure you're doing one mean. And that's when you would be doing the n-1 degrees of freedom. Ready for the next question? Here we go. Everyone get ready. Here we go. Which of the following is not a condition for the confidence intervals for the difference between two means? So, which of the following? Remember, it is a public video, so mods can see that. I think Caitlin can see that she's a mod. So Caitlin can see that she's a mod. Which of the following is not a condition for the confidence interval between two means? Now, what is condition 1? Who knows condition 1 right here? What is condition 1? Who knows condition 1 like that? Because condition 1 is one of the conditions. And how do we know which one it is? Maya says random. So condition 1 is random. Condition 2 is then what? So it means we randomly select individuals. That's condition 1 is random. It's always the same first condition. Condition 2 is now what? What is now condition 2? 10%, which means less than 10%. It's not on here, but it's one of the conditions. Less than 10% of the population is sampled. Keep asking questions and keep answering. This is your practice right here, and you're doing great. Thank you, Lindsay, Grace, Troy, Lindsay, Emily, and Abigail, and everybody. Michaela talking in the chat. Now, here's where we have to do what? What do we do? Who knows our famous saying that we always say right here when we get to the third condition as I pull up the conditions right here for those who have not seen it? What did we do when we get to the third condition? If you don't have a screenshot of this by now, you should have it. What do we do when we get to that third condition? I know one class is going to be saying our famous line we always say when we get to here. We say pause. We say pause. So we pause when we get to the first. There's the pause in the chat from Maya and Ella. We pause. Kahoot pin is right behind me right there. Oh, you should. Oh, sorry. There you go. Sorry, it'll appear in here a second. So the third condition is where we have to pause and we have to ask, what kind of data are we working with? This right here, and we'll take some marks on it real quick. This right here is categorical. This right here is quantitative. And this is the chi-squared where you have two categorical variables. And then down here, this is quant, but 2 sample t. So this is 2 t-test. And then down here, this is also the chi-squared test of independence. This is a good kind of review right here of the conditions and knowing which condition to use. Who feels like they have the conditions pretty down? Like, you know, when you're going through them, if it's categorical data, you're going to use success failure. If it's quantitative, you're going to use nearly normal large enough n. And we went through that a little bit today, like when to use large enough n, when to use nearly normal. Large enough n is for sampling distribution technically, and I kind of use them interchangeably. But large enough n is for sampling and nearly normal is for the 2 sample t-test. 75%, good deal right here. This is a good review. This is the cheat sheet on it right here. Let's show that Kahoot pin again, and let's see who's in the lead. That's a shakeup of the leaderboard right there. That is craziness, just absolute nutter. Oh my God. Let's find out what's going to happen right here. I don't know who's going to win. This is going to be insane. Keep playing along. If you don't win the Kahoot, that's all right. Remember, there's a $50 grand prize. Who's going to win? When doing a 2 sample t-test, the variables will be what? This is a 2 sample t-test. So we kind of were just reviewing this a moment ago. We were talking about the 2 sample t-test. So when you think about T, we have to remember Mr. T is mean. I'm sure he's a nice guy, but he's mean if you're doing drugs. And why do we say that? Why do we say Mr. T is mean? Because one of those variables is going to be quantitative, which means we can't be doing this one. This one's chi-squared. Does anyone know? Let's eliminate. Ooh, this was a tough one. This was the most answered question. What technique are we doing for this? This is really good. This is a good tools and techniques review. If you have 2 quantitative variables, what are you doing? If you have 2 quantitative variables, and I can show you this, I'll show you 2 quantitative variables. I'm glad this is where we try to figure out, if we have 2 quantitative variables, what are we doing? So if we have 2 quantitative variables, here's what it looks like. And what are we doing? If you have 2 quantitative variables, what are you doing? Not chi-squared, that'd be too categorical. If you have 2 quantitative, regression. Regression is 2. Thank you. Yeah, SI review is amazing. Thank you, Matthew, right there. Shout outs to Alyssa. She's doing a great job. So that's regression. So if you have, let's take a look. Let's see when we get this right here. When we do the 2 sample t-test, we could go over here to like Greek life and GPA. We did that during office hours today, or during review today. This is a categorical X and a quantitative Y. And it's because the 2 sample t-test compares the what of 2 groups. A 2 sample t-test compares the what of 2 groups. Just think about, like, by doing t, we're comparing the whats of these groups. This is the difference between the whats of the groups. And there's 2. Great job, Kaylin, right there. We're comparing the means. So when you have the categorical variable, which might be confusing, you're like, wait, we're comparing means, but it's on the x-axis here. Does that make sense that we have 2 groups right here? We break it apart on a categorical x, so you have 2 categories, and then you compare the mean for this group versus the mean for that group. And that's the 2 sample t-test. The 1 sample t-test would kind of be, and I wish I could show it, it'd kind of be just if we just look at that, which we don't have the data for it right now, but that's a 1 sample t-test if you just look at that data. And does everyone see how it's a 2 sample t-test now? Who's being like, oh, 1 sample is when it's 1 group, 2 sample is when it's 2 groups. That's what the 1 and the 2 mean of the 2 sample and 1 sample. If you want to do a 1 sample t, you would just take one variable like age, and then you would just have a histogram right here or something of the sort. You could do a box plot also. But this would now do a 1 sample t-test or 1 sample t-interval, because this is all just 1 sample right here. There's no 2 groups that it's broken apart between. So hopefully that differentiates. Please ask questions, but there's a categorical X and a quantitative Y. So would 1 sample just be quantitative? Because remember, Mr. T is what? So Ben, great question right there. Let's throw some 100 points. Everyone chatting. Mr. T is what? So one sample t would just be what? One sample t, which this is, because age is quantitative. So this would be a one sample t test or one sample t interval over here. That's a one sample t interval right here. Does it say that? It doesn't say t on it. But Mr. T is mean. So we remember t goes with the mean. If you're doing drugs, don't do drugs. So here we go. Let's see who's in the lead. Oh, leaderboard's going crazy. Legend Dolphin. And I want to point this out. The final question's worth double points, and Tiny Brian's here to announce it. And it's going to be a review question from class. Tiny Brian, still seeing if he has scurvy. Stay tuned for Tiny Brian at the end of the lecture. Here we go with the next question, which is not a way to check the nearly normal condition. I've been mentioning this a whole lot lately. One of these should jump out and be like, nope. When we're dealing with quantitative data, one of these just does not work. I do pity the fool that does not like statistics. I don't know. It's all right if you don't like stats. I love stats. It helps. It helps with studying it. It helps with teaching it to like a topic. Don't worry, I'm not covering up the right answer. Because we can do all of these except for make a what? All of these are right answers except for bar chart, because bar charts are for what kind of data? So I hope this graphic makes sense. I'm covering up the categorical box right now, but bar charts are only for what kind of data? Bar charts, and look, so hopefully it's starting to make sense. We've got some color coding on this. The green ones are all categorical, like the only variable involved, but bar charts are univariate categorical. That top row up there is for one variable displays where you don't have an X variable, you're just analyzing one variable. So bar charts are categorical. So this goes back to the question we had earlier. If you're doing quantitative stuff and you want to check nearly normal, because that's one of the conditions, you have to do quantitative displays like histograms or a goodness of fit test. The goodness of fit test literally asks if the normal curve is a good fit, and the normal probability plot tells us the probability of the plot being normal. So it's testing to see if it's normal. So all of these are correct except bar chart, because bar chart's for categorical. Also, you can't do it with a pie chart either. This is anyone's game. I'm telling you, like as the leaderboard just shifts around completely, this is anyone's game. People on the top of the leaderboard might fall off. People on the bottom leaderboard, you don't know. If you got 0 points right now, don't worry. Let's see who's going to win right here. At least try to answer fast. Like, I'm going to answer one of these questions the quickest. Let's see who's going to win with the next question. A researcher wants to examine the true GPA of UT students. What tests would they use? So you have to identify what kind of variable is this. They're trying to understand GPA. That is a quantitative variable. When I get a question like this and it's tools and techniques, because a lot of people wonder what our tools and techniques can be like, I'd say, okay, they want to analyze one hint, quantitative variable. That should be a huge hint, because regression is two quantitative variables. Chi-squared is categorical data, like do you own a pet and do you live on campus or off campus? And two sample t-tests, we'd need to have something like GPA of students and where they live. And everyone got it. So great review right there. I like putting questions in here that if you're following along, we can do some practice on it. We're just analyzing one quantitative variable, and we analyze with a t-test. That can just be called t-test. One sample t-test is kind of the equivalent, but that's a t-test too. But a lot of times you want to call it a two sample t-test, where there's the two means. Just if anyone's watching this question, as a quick review again, here's what the two sample t-test looks like. There's two groups. So you got a categorical variable down here. And here's what a one sample t-test would look like if we just had one group. That's why it's called 1 and 2 sample. So we can do the test right there. Great job. Please ask questions if you have it. Doing as many questions as we can. There's a 20 question Kahoot, $50 grand prize. Oh my gosh. Let's go on. Let's see who's going to win. It is anyone's game. Dr. Camel. You can't beat a Dr. Camel. That's like, who let that camel into doctor school? I was like, I don't know. Dynamic Cheetah, though. I like Dynamic Cheetah. I like that name. That's maybe the coolest name I've seen so far. If you want to put your name in the chat, what it came up with random generation for you, let me know. Let's find out who's going to win right here with the next question. To examine the difference between GPAs of students and if they own a dog, what kind of tests will they use? Here in this degree. There you go. So we've got GPA, which is quantitative. Don't worry, I'm not covering up our right answer. We got GPA, which is quantitative. And then we've got if they own a dog, yes or no. So we got like two groups right here. We're analyzing the GPA of students and if they own a dog. But remember, we're trying to understand GPA. So that's the Y variable of interest. So this is an exact review of what? I'm going to ask a follow-up question. Great job. And then what graphic could we use to display this? Since this is a quantitative y and a categorical x, what if the tools and techniques question said, what graphic can we use to display this? So who knows from doing all your practice, you've gotten a lot of jump work, a lot of good practice. What graphic can you use to display it? What graphic? Not a mosaic. Great guess right there, Maya. Kiana, great job right there. Side-by-side box plots. Decision tree would technically be correct. So we can see we have one up here a moment ago. And let's go ahead and do this and go to quantiles, and we get side-by-side box plots. No, don't worry. Great job, everybody. This is really good review. When would you display something with a mosaic plot? When would you display something with a mosaic plot? When both variables are what? Like, how could I get a mosaic plot displayed on here? I'd need both variables to be what? If I were to have a mosaic plot, I would need to say both variables need to be what? Categorical. And this is the good tools and techniques practice. And then what test would I run on this? This is good practice. So mosaic plot is or contingency table is categorical. You can see the categories. And then what test would I run down below? Harrison, great job, Harrison. Chi-squared test of independence down there. Chi-squared, great job, Ben. And so you can see the chi-squared test of independence right here. We got some graphics on this, and we can see how this is all done. We did a really good review of this today where we were calculating expected counts and cell chi-squareds. Definitely check out the chi-squared review. I don't think I have questions on here tonight about calculating expected and cell chi-squareds, but today we did practice. Caitlin can tell you we were practicing chi-squared. People were getting it down. So check out the chi-squared video, which I just re-uploaded. I edited a little off the ends of the videos just to make them a little more cohesive. But who's in the lead? I tell you, it's anyone's game. We did a lot of great practice, and I'm really excited because this game, gosh, look at this. Just a couple hundred points. I want to see the leaderboard shake up again. Hopefully we got some difficult questions. Let's find out with the next one. Here we go. Favorite restaurant versus living on and off campus. We asked people, what is your favorite restaurant? Do you live on or off campus? What kind of test would we use? This is a great review question now. So you need to identify in this very short question, favorite restaurant is categorical. Do you live on or off campus is categorical. This could be displayed with a mosaic plot. This could be displayed with a contingency table. So mosaic plot, contingency table are big hints. Categorical, this is count data. We're talking about that chi-squared test of independence. Great job right there. So chi-squared test of independence has a fourth condition. The conditions don't have any order, but I like to tell them they do. So the chi-squared test of independence has count data as the condition. What does the count data condition mean for the chi-squared test of independence? When we talk about the count data condition, what does it mean for the chi-squared test of independence? Because we have here favorite restaurant, like you could say like Taste of Thai, amazing. You could say here, do you live on or off campus? Off campus, I guess now. I've lived on campus forever. So each of these right here are categorical variables. I see people mentioning the expected cell count condition. Great job, Layla, right there. That is the third condition, which is at least 5 expected cell counts. So when we have the count data condition, both need to be categorical. And that means we're doing the chi-squared test of independence. We make mosaic plots. And we saw that just a second ago right here. This is the kind of test we'd be doing. We'd be analyzing something like, have you broken a bone? You know what? Let's see if your order in your family. I'm the middle child. Oh, look at that. What does that look to people? I want you to use a word right here and say, hey, Brian, that looks pretty what for this test? That almost like the order you're born in your family and whether or not you've broken a bone. You know what? It's interesting. Only childs have broken bones a little bit less, but I don't think it's a big enough of a difference. These two things, family order and broken a bone, look pretty independent, which is the null. I'd say they look pretty independent, and look at that p-value down there. The p-value right there concludes that they are, at least we fail to reject the null. Great job, Michaela, right there. We fail to reject the null, that they are independent. We continue to believe that they are independent. Like, it looks like the differences right here are probably due to what? I'm sure someone knows in the chat. I'm sure someone knows the differences here look like they're probably just due to what? Random chance. I would say that's just random chance differences. Okay, let's go on to the leaderboard right here. Let's see who's in the lead. Legend Dolphin. Woo, Legend Dolphin. That's cool. That's like the name of a video game or something. Like, I was playing Legend Dolphin this weekend and I beat all the stuff. I got to get the new DLC for Legend Dolphin that includes Dr. Camel. Let's find out, though, how the next one goes. I love that button, too. Fan favorite button. Thank you, Jason, for making those screens. Next question. Here we go. Which of the following is not a valid alternative? So all of these are valid alternatives. You know, we put the HA before it, the alternative states. And we're testing a proportion here, which means we'd be looking at something like the true proportion of people who own a dog is equal to 36%. But once again, that's not an alternative. That's a null hypothesis. And I did just give Dr. Kimmel's extra didn't. Not bad for some DLC there, Kyle. Kyle, that's awesome. That's worth 100 points. Why is this the right answer for it? Yes, correct. Great job, Caitlin, right there. The null hypothesis is the only one with the equal sign. Everything else can have greater than, less than, or not equal to. So the null hypothesis has the equals. The null has the equals. The null has the equals. So right there, we see the null has the equals. The alternative is either greater than, less than, or does not equals. What do we call the does not equals? Kind of, sort of. It just means we're starting out as it with our initial belief. So Michaela, you might be thinking about the chi-squared test of independence, where we actually like write that this is independent of this. These, for every other chapter, we write the null and alternative as statistical notation. The chi-squared chapter is unique. Does that make sense? And people are pointing out that it's different. It changed. It's the two tails. Correct. That's where we shade both sides. We'll have a p-value question 19. But this is the two-tailed test on the far side that I've highlighted right there. Jolly, yes, Jolly Otter. Ooh, it's going to be a close game, everybody. Don't leave. Stay in here till the end. I'm glad we have over 100 people playing, which is awesome. If the channel ever gets really big, I'd love to do Kahoots where we like pay for someone's tuition. What would people think of that? I can't do that yet, obviously. But what if we, I don't know, we need to keep growing, and I hope more students at other universities can use our channel to learn statistics. That's my hope. Is I think we do a great job on this channel. I think we help each other out. We have this community, but if one day we got really big, hey, we just do like, hey, this good. Elon Musk needs, hey, if he ever wants to do that, that'd be awesome. Because right now we're not that big yet. Exactly. Let's do this right here. We are Stat Nation. We are the best. We are the best community here. We're the best community. I get like real like half quick, real second here. I'm gonna put on. I don't know. I'm gonna put on music. I'm not gonna like do some emotional. I mean this. It was our class last mini term that came up with the name Stat Nation. So it was students who made up that name, and students who like that name. And it really is you guys who make this community. Like, I'm not trying to be all some YouTuber who says all these things. If I come on here and just teach, it's not me. It's people in the chat right now having fun, making jokes, you know, all this great stuff right here, cracking each other up. That's what makes it. So just realize that any class you're in, you're a big part of that equation. You're a big variable in the class. So be there for each other, help out each other. Let's see who's going to win the Kahoot. Let's do this. I'm going to Disney. The central limit theorem states that the distribution of the sample mean will do what as the sample size increases? Two things right here. Two things. Whew, it'll do two things. Well, what we're talking about here is the distribution of the mean, which is when we ask people a quantitative question, like, what is your GPA? And this distribution will do two things. Well, one, we want to use the nearly normal condition, so it will get more normal, but also, well, that's the answer. I was thinking about it. It'll get tighter, which means the standard deviation will get smaller. Watch me get it wrong. No. Okay, so the two things. Here's what you want to write down. The central limit theorem states two things. The distribution of the mean will get more normal and tighter. Oh my gosh. Look at all those. I closed down today after because we had so much. So if you have a distribution like this that is skewed, and this is the distribution with a sample size of 1, if we increase the sample size, the new distribution of the mean, so this is where n equals something like 25, will be the two things, more normal and tighter. More normal and tighter. What do we divide it by? The square root of what? So the original standard deviation up here is just sigma. But down here, the new standard deviation is sigma over square root of n. Sigma over square root of n. And the original mean is mu, and that's the original mean down here. So this is sampling distribution of the sample mean, where the new distribution is more normal. It can eventually become normal enough. basically the nearly normal condition, and then we divide it by the square root of n, so that's it getting tighter. Does that make sense there right there? Great job, Elizabeth and Ella and Leslie and Michaela. So this is the distribution of the sample size of 25, which means we take 25 dots from here. 25 dots, and 1 dot is the mean of those 25. Does that make sense that we take 25 dots and we take the mean of it? It's a little dots. It's a little confusing to think that, oh my gosh. It's a little bit confusing to think that each observation is 25 dots all averaged together. He's returning today. Tiny Brian will return at the end of this lecture or at the end of this Kahoot. So remember 2 things. 1, it gets more normal, and 2, it gets tighter. It gets more normal and tighter. I'm glad. It's one of my favorite quotes too. Oh my gosh, leaderboard is so tight right now. Let's find out. Legend Dolphin versus Dr. Camero, but Dynamic Mouse is not going to let this stand. Dynamic Mouse, you got this. You got this. Snoopy. Here we go. Quiz question. A confidence interval goes from 10 to 40. The margin of error would be what? You got this. Be very careful. Remember, the margin of error is half the length of the interval. That's what you should say in your head instantaneously. When you see this, the margin of error is half the length of the interval. How do we get the length of the interval? To get the length of the interval, we do 40 minus 10. That is the length of the interval. So the length of the interval is 40 minus 10. There you go. Make sure to put the exclamation mark start of it. The length of the interval is 40 minus 10, so the length is 30. That's the length of the interval, but the margin of error is half the length of the confidence interval, half the length. So the margin of error is half the length of the confidence interval. Remember that. Anything that asks you about confidence intervals, or if you're ever having to calculate margins of error, remember to do half the length of the confidence interval. Great job right there, everyone. How did the game change that much on that one? That is so interesting. What happened? Joyful Lemming, Social Raving, Legend Dolphin still in the lead. Here we go. Let's find out. Oh my gosh. True or false? Increasing the sample size will make the margin of error smaller. What will increasing the sample size do? Just think about this theoretically for a moment. Great way to ask the question, right? Margin of error is uncertainty. So if you are, collecting more data, larger sample size, would your uncertainty go down or up? So like you get more data, what happened to your uncertainty? Your uncertainty is going to do this. And what am I showing you right here? That your margin of error, if you increase your sample size, your margin of error will do what? It will get smaller. This is very true. We can see this formulaically. The formula we need to look at for this, any sort of margin of error formula will do, but we can do y bar plus or minus t star with n minus 1 degrees of freedom, s over square root of n. What happens here as n gets larger? The what gets smaller. So as n goes up, which is the sample size, this portion of the equation right here is the margin of error. So the margin of error, I don't think I can do that then. The margin of error is going to do what? You can explicitly think about like this portion right here, but it's also multiplying by something. Yeah, great job, Kiana. This is a great, I'm glad that we're hitting upon the same things. Alyssa is excellent. She got SI Leader of the Year. Shout out to Alyssa. Tell Alyssa thank you. We are very honored by her. So increasing the sample size will do what? You can, if you win, you can tell Alyssa, be like, I won because I went to your review. There's quotes I don't even remember. So does everyone see right here, as we increase sample size, the standard error will get smaller. And if this gets smaller, what happens to the margin of error? Does that make sense? Is everyone good on this? I think everyone's good. Everyone's having a great time right now reviewing, but if you increase the sample size, that'll make this smaller right here, and then this will make the margin of error smaller. So great job, everyone right there. Let's see who's in the leaderboard. Fuzzy cat. There we go. It is pretty crazy right now. Everyone's checking out all those quotes, but focus in. It's time for the next question. Let's see who's going to win right here. True or false? The central limit theorem states that the more data you have in your sample, the closer the shape of the histogram of that sample will be normal. So basically, when you have a larger sample size, the distribution will be more normal for the distribution of the sample mean. The shape of the histogram for the distribution will be more normal. And this is for the sample mean. Sorry if I didn't make it clear enough. This one is for the sample mean. This one is for the sample mean. So that is true. So when we're talking about the shape of the distribution of the sample mean, I hope I made that very clear enough, but it's going to be more normal and water. What will it be? And I believe they're recorded. It'll be more normal and water. Yeah, Alyssa is just awesome. More normal and tighter. Great job. I'm really honored by our SI leaders who work so hard, and more normal and tighter is the two things about the central limit theorem. So excellent work right there. Ooh, legend. Oh my gosh, look at this whole leaderboard. This is craziness. Like we got some really good stats people right here. This is going to be crazy, everyone. People are like focused. I can like see the focus. Like I'm cracking jokes and people are ready. Let's do the next question because I don't know who's going to win this because people are really focused right now. I'm going to keep trying to drop knowledge as people just, the t distribution is like the normal, but is different in what way? What way is the t different from the normal? The t is basically the normal. Ubot, tell us about that t distribution. The t is basically the normal. It's definitely not bimodal. Someone's like, no, it's definitely not multimodal. No, something different about those tails. Ubot, thank you so much. You're so helpful.
I am Ubot.
Thank you, Ubot. So there's more area in the tails. So here is the t distribution right here. And you can especially see it when we do like 1 degree of freedom. Just kind of look at the tails here under 3. As you increase the degrees of freedom, it starts to become more normal. Because remember, Mr. T comes in, he says, "I pay fool," and smashes it down, and then it's less normal. So we have right here a T with very little degrees of freedom, but as the degrees of freedom increase, the T approaches the normal. Eventually, it basically looks like the normal. This is the one that William Gossett created. When do we use the T? When we're doing what kind of data? What kind of data do we have when we're dealing with the t? When we're doing a t-test or t-interval, we're dealing with the sample what and the sample what means. Sample mean and sample standard deviation. We only have the sample mean and sample standard deviation. That's when we're dealing with t. Mr. T is mean if you're doing drugs. So make sure, and yeah, you are correct, Ben. That would be a 2-sample t-test right there. Ben is correct. So remember, Mr. T, mean, only if you're doing drugs. I'd hate for anyone to think, because Mr. T is just awesome. So I'm an 80s kid, so respect to Mr. T. Thank you so much. When do we use Z? So the Z can be used for the sampling distribution of the sample mean and proportions. So I'll write this down right here. I'm going to take some notes. Thank you so much for all the questions right there. Please ask any questions you have. So here is T is going to be, perfect, right? 2-sample t-test. So that would be right here, would be quant y / cat x and 1-sample t-test. Let's just go 1-sample t. These are intervals or tests. So like 1-sample t can be an interval or a test. And this would just be a quantitative y. And then when you have z right here, not x, when you have z, you're going to be doing 1 proportion, which means we just have a yep, that's correct, categorical y, or sampling distribution of sample mean. So in this instance, we know the true mean and we know the true standard deviation. I know this is under mean. This is when you're doing the thing. Let me show you right here. This one exception to the rule, and you do get this on the formula sheet, is when you have z equals y bar minus mu over sigma over square root of n. So this is the one instance right here when you're doing the sampling distribution of the sample mean. And it just always irks me that, but that is when you know the truth, you can actually use z. But in all other instances, you'll never, like here for categorical, you'll use z. One way to memorize this is sigma z, and then up here you have s and t. So that's another way right there. It's from 1 to 3:15 on Tuesday. Thank you, Dallas, for asking. So sigma z, if you see sigma, you're using z, and when you have s and t. So great question right there, and hopefully that helps differentiate between these right here. Sigma is the true standard deviation. So in this instance, we know the true standard deviation, and we also know the true mean. This is true standard deviation. That is sample standard deviation. This is the true mean, and this is the sample mean, and this is the sample size. Great questions. Thank you, everyone, for asking. Always feel free to shout out those questions, especially in between questions. We'll try to answer them all. Let's see who's in the lead. Oh, Legend Dolphin is back right here. So got some Season 2 DLC with Snowy Octopus right here. Let's find out who's going to win right here. Next question. When the p-value is below alpha, oh, this one, someone's going to be quick right here. Rockstar Tiger? What is that? Was that on the leaderboard? Did I miss that? When the p-value is below alpha, please don't answer the question. That's just going to hurt my soul. I'm not blocking the right answers, but please don't answer the question. I'm just going to be like, no. Please, no. Don't answer it. Don't do it. Don't click that button. Every person who clicks that button is just going to hurt. I'm just going to be like, no. We don't say that bad word. We don't say that word here. We don't say that here. Oh, 7 people. I'll take it. It's fine. It's fine. It's fine. When the p-value is low, reject the null. When the p-value is low, Rockstar Tiger in the chat right there. When the p-value is low, reject the null. That's some Davey504 playing Hello Darkness. He's never DMCA'd us, so thank you, Davey. Short clip right there. When the p-value is low, reject the null. When the p-value is high, do what? When the p-value is high, just do what? When the p-value is low, reject the null. When the p-value is high, you can say the actual thing. When the p-value is low, reject the null. Just when the p-value is high, just let it fly, which means we don't reject the null. We fail to reject the null. We either reject the null or we fail to reject the null. So either reject the null or fail to reject. I like it right there, Daria. Let's do it. I love that, Daria, right there. Or fail to reject. You got it. Great practice in the chat right here. Daria right there. That little blue burrow got everyone another 100 points. Thank you, Daria, right there. Don't say that right there. Oh, man, if Davey504 is welcome to a collab with us right here. I was going to do a speed run for him and like tag him, but I have a lot of ideas. We're always open to that, Matthew. He does random stuff. You never know. A lot of random things, though. So he makes really great content. So shout outs to Davey504 right here. He needs our shout outs. He doesn't. Okay, who's going to win right here? Let's find out with the next question. Here we go. Next question is, when constructing a confidence interval for a mean, which of the following do you not include in the interpretation? Ooh, what do we not include in our interpretation for the confidence interval for the mean? What do we not include in the interpretation? I am blank % confident. Well, that gives you one of the answers. That the true blank, whatever we're talking about, the true mean GPA of UT students is contained in the interval blank to blank. I am blank % confident. I am blank % confident that the true mean of the true mean of UT students is contained in the interval blank to blank. The only thing you did not hear me mention is a p-value. Because p-values are when we do whats. P-values are when we do a what. When you do a p-value, you're doing a statistical something. So you always get a p-value when you're doing a statistical this. P-values, you always get those by doing a what. P-values, you always get a p-value by doing a statistical what. Well, p-values are probably great job, Michaela, right there. The p-values are probability, the probability of our results, or results from our stream having a random chance variation, given that the null is true. Michaela, I'm throwing you 100 points right there, and everyone else, because sometimes it's the hardest to be the first person to answer. You're like waiting for someone to answer. You're like, I'm not going to answer. But no, Michaela just got everyone 100 points right there. Thank you so much, because the p-value is the probability of our results or results from our stream happening by random chance variation, given that the null is true. It's definitely a probability, and it's found when we do a statistical test. So we are finding the probability of our results or results from our stream. We reviewed that today, and I did it a lot slower. So if you're wondering what I'm talking about, check out the reviews from that. And we do go into more detail on like what is a p-value. We spent about 3 minutes like talking about it and graphing it and showing it. So check out those reviews and always ask those questions if you have them. Who's in the lead? Let's find out. Rockstar Tiger. I mean, that's we're talking all video games today. That's like the second that I don't even know what I'm saying. I'm trying to say that's the follow-up game right there. Rockstar Tiger, I know you're in 3rd place. How many questions? I think there's like 40 through 50 questions. I think similar in length to all the other tests. Great question right there. Let's find out who's going to win with this next question, because it's a crazy game. Here we go. So we've got here the null hypothesis is 5.2. The 98% confidence interval goes from 3 to 4. You would reject the null at the 0.02 level of significance. So you are testing to see if 5.2 is the true mean. You have 98% confidence interval that goes from 3 to 4. You would reject the null at 0.02 level significance. Well, immediately think yes or no. Well, 5.2 is outside my interval, so I'm going to say yes, and actually that's the answer. Michaela right there. Let's see. I shouldn't have said the answer. That is correct. This goes to the idea right here, Hampton. We're going to throw out some points here in a second. Thank you, Hampton. So we have right here that 5.2. And how does this work? Whenever we do confidence intervals and tests, if you have a value, I'll reappear right here. If you have a value that is outside your confidence interval, like let's say we have a confidence interval that says the new Nintendo system is going to cost between $500 to $700. So what would you say if somebody told you they think the new Nintendo system is going to cost $1,000? If someone said, I have the null hypothesis that the new Nintendo system, the average price will be $1,000, like in retail stores, what would you do to that null hypothesis that the new Nintendo system, with your interval right here, what would you do to that null hypothesis? They say, I believe that the average price of the new Nintendo system will be $1,000. And you're like, well, I think it's going to be between $500 to $700. You would reject it. And the way it works is whenever we build a 95% confidence interval, or 98, whatever we build, we can find the relative two-tailed test that has an alpha that is just 1 minus that percent confidence. Does everyone understand how I'm getting this alpha right here? Great job, Michaela, right there. We can reject values outside the interval. So when you build this interval right here, which you can see right, oh, I'm grabbing everything right there. With this interval, it would go from here to here. And if anything is outside the interval, we can reject it. Alpha 1 minus confidence is the two-tailed test. Great job, Michaela, putting notes in the chat right there for everybody. Awesome work. That's another 100 points. Why not? So keep putting those notes in the chat. Keep practicing and knowing that a two-tailed test is just like a confidence interval with the complement alpha. When we say complement, we just mean they add up to 1, 95%, 5%. And you can see it visually right there that the two-tailed test is like the confidence interval for a 95% confidence interval. So great work right there. Excellent words. So if it was 600, you would fail to reject. Elizabeth, great job right there. What about if it was 680? And kind of, Michaela, yeah, don't worry. We won't put it on the test, but that's a great answer, Michaela. You are correct. If someone thought of 680, would you reject or fail to reject 680? If someone thought 680 was the truth, like, because hint, you can pick whatever you want to be the hypothesized value. You would fail to reject. Very similar to this, Bailey, very similar to the other exams and very similar to this because there are actual exam questions on this. Obviously, there's more questions and we have question banks, but I can promise you, you might be taking the exam and be like, wait a minute, I saw a question just like this. I'm not saying you have the right answer right here. Thank you so much, Daria. I do have a lot of points. I've got a lot of time. You can see how long I've been on the channel here, how long I've streamed. Oh my gosh. It'll be interesting when we get to the 1 year point because I started the MuBot in like September of last year. So when we get to September next year, I'll have to look because I've streamed a total of 442 hours. That's almost 20 days of streaming, like 20 days of being streaming on the internet. Like not like I streamed 20 days, but that's about like 18 straight days of streaming. Yeah. Well, that's a lot of time. Anyways. What percent of my life do I spend streaming on the internet? Sizable portion. Let's continue on here. We got Legend Dolphin still in the lead. Here we go. Let's find out who's going to win. Oh my gosh, we're getting to the end. Which of the following are 3 things that directly impact power? You've been here for 66 of them. That's so awesome. Great job, Ella. Which of these directly impact power? All of these impact... So all of these things impact power. As they impact beta. And the 3 things that impact beta are what? Well, one, we have how false the null is, and that's the effect size. And I think effect size is the most confusing one for people. So power is the complement of beta. So if you're wondering why power is the only wrong answer here, power is found by doing 1 minus beta. So 1 minus beta is power. Power is the ability to correctly reject the false null. I want you to imagine you work for a company and you are trying to decide let's say, should you buy new digital ads? We shouldn't buy ads. We shouldn't buy marketing. Sure. Alternative, we should buy it. So we're looking at this new marketing company and we're trying to figure out, should we buy ads? Let's talk about what power is. Now, there is a truth that exists. There's a truth that exists. Let's say the truth is the null is false. What does that mean we should do? If the null is false, no, Elish, no. If the null is false, what should we do? And this will get into type 1, type 2 error for a moment. If the null is false, what should we do? Just pretend the null is false. Like this right here is a false statement. That is a false statement. We should reject it. Does that make sense? So what kind of error would we be fearing right now? Like, let's say the null is false. Because power, I can't go for it. Yeah, sure, we'll put it right here. Power is the ability to correctly reject the false null. Power, which you see the formula for right there, is the ability to correctly reject the false null. You'd fear a type 2 error. They are inversely related, and that's what impacts beta right here, which impacts power. So think about this. What could you do to just never make a type 2 error? Whenever you're confronted with marketing opportunities, what could you do to never make a type 2 error? Because you were looking for evidence that you should do the marketing thing. So we should buy the marketing is the alternative. What could you do to never make a type 2 error? What could you do to never make a type 2 error? You could always do what here? You could always reject the null. Great job, Ben. You could always reject the null, and then you would never make a type 2 error. Does that make sense to everybody? Like, if you always reject the null, you'll never make a type 2 error, but you'd make lots of whats, though. If you reject the null when the null is true, like you should not buy the marketing, if the null is true and you reject it, you've just made a what error. If the null is true and you reject it, you've just made a what error. You've made a type 1 error, and that's kind of, I think it was Michaela was mentioning, because now we're increasing our type 1 error, but you've just done what to your type 2 error? If you increase your type 1 error, you've done what to your type 2 error? Because they're inversely related. If you increase your type 1 error, you will decrease your type 2 error. But what if our company said, we want more data? Do you think that'd help us make a better decision? And what are we doing if we say we want more data to make this decision? What are we increasing to say we want more data? Which will then have less type 2 error, will make less mistakes. Type 2 error is basically missing out on an opportunity right here. The risk is always there, but would it be less risky with more data? And the answer is yes. Does that make sense, Michaela? If we have more data, it'd be less risky because we're less prone to error then because we have a better understanding. If we increase our rejection, that could be iffy. Like now we're saying we're more willing. This is like risk adverse. So you think about like supply chain, and I had a really good talk with supply chain people recently. I'm going to be at their forum in November. I don't know. I'm really excited about that. But they were talking about risk. And if you want to like increase your type 1 error, that you're willing to make that risk to probably get opportunities if they're worth it. Yeah. But here's the hard one for people a lot of times is effect size. And we go over this today. Effect size is, let's say the truth is this marketing opportunity will make us $10 million. Like if Elon Musk were to come up to you and say, hey, I've got this idea and I want you to have it, what would you say? I mean, we don't know the truth, but I mean, it's Elon. He gets all the shout outs in our class. So if he were to walk up to you, you might be like, you're like, wait, why are you here? But you'd be like, okay, this seems like something that's going to make a lot of money. What if your random friend who comes up with ideas all the time gives you an idea? You might say, I don't know if that's going to be that big of a effect size. Like maybe that's not going to be that easy to see. We go over this more in depth today. Effect size is probably the more difficult one. It's the difference between the null and the truth. And the bigger the difference between the null and the truth is, like if the opportunity would make us $1 million, that'd be easier to see than if the opportunity is only going to make us $100. So effect size, when it's bigger, makes it easier to, or it's going to lower beta, which increases the power of the test. Are these more math-based? There's some math, there's some theory. It's a good mix. It's a really good mix, Michaela. Great question. What does beta mean? Beta is a what? Beta is directly what? Great question right there, Ben. Who knows what beta is? It's the probability we make a what? Beta is what? Beta is the probability we make a what? It's a good review right here. 1 minus beta is power. So 1 minus beta is power. Beta is a type 2 error. So power is not making a type 2 error. Does that make sense? Power is 1 minus beta. So if we decrease beta, we increase power. I'm going to draw out what I usually draw out for this. So the three things that impact beta are going to be the following. So we have sample size, alpha, and effect size. The only one we really can't control is effect size. If we increase any of these, we can't really increase effect size. And type 1 is alpha. Great job, Ben, right there. So if we increase any of those, beta goes down, and then power, which is 1 minus beta, goes up. So increasing your sample size makes your test more powerful. Increasing your alpha makes your test more powerful. Having a larger effect size, which we don't really control for, increases your power. And one way we memorize it is 1, 2, A, B. And then usually I call type 1 a false positive a lot of times. So you're rejecting the true node. Do memorize this though. In a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. Tiny Brian's going to be here in just another question or two. Get ready. It's a close game. Who's going to win? I don't know. Rockstar Tiger, no. My gosh, this is craziness. Last question's worth double points, so you're not out of it yet. You might just try just long pass towards the end zone at the final question. Let's give this a shot right here. 2 more questions to go after this. The hypothesized value in a null hypothesis can be any value we want it to be. So we can hypothesize any value. We can just be like, I don't know, the mean GPA of students is 3.8. With anything within the theoretical possible realm. You can't be like, the GPA is infinity. Well, that's a concept, so we can't use that. You can't use proportions that are outside 0 and 1, but they can be any value we want. We can just be like, sure, let's hypothesize this value. So the hypothesized value is any value we want it to be. Very true. Very, 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 very true. You can just be like, let's test this value. This is just the idea of the researcher coming up with a question being like, I want to see if the GPA of students at this university is greater than a 3.0 or 3.5. I don't know. That's a much better goal. Don't worry, I didn't know about 3.0. But we want to see if the GPA is above this certain amount. So we want to test it. The null is that it's equal to 3.0. The alternative is that's greater than 3.0. Now get ready. You might want to have your calculator out. This next question will not be hard with a calculator. I just want that picture of... So get your calculator out. Who's ready? I need some eyes in the chat as we look at this leaderboard. You want your calculator out for the next one. So let's see. Leaderboard is going absolutely crazy. Rockstar Tiger back on here. Joyful Lemming. Where is the doctor? We've lost the doctor. Everything's crazy. We're starting this next question in 5, 4, 3, 2, 1. Here we go. Amazon dog. Love it. What is the p-value for the greater than test? Ooh, got to look in close right here. The greater than test is missing. But you should know that the greater than test and less than test do something. And hopefully I haven't typed a typo in here. I don't think I have. Okay, good. I think I... I'm so worried. This is one of the new questions I added on. Ooh, this is going to shake up the leaderboard. Something good. Leaderboard's about to go crazy right here. Ooh, this was a tricky one. The greater than test and the less than test add up to what? The greater than test and the less than test must add up to what? The greater than test and the less than test must add up to what? So the greater than test and the less than test must add up to 1. Great job. And there's the answer right there. How could we get the two-tailed test? How do we get the... I almost blanked out the other ones on this one. How do we get the two-tailed test? We take the smaller one and do what? So the two-tailed test, as you can see here, the two tails to it, we take the smaller one, the smaller of the p-values, and we times it by 2. And there's the p-value for the two-tailed test. Great job right here. 2 times the smaller one. Great job, Adriana, right there. Adriana is saying exactly what we need to know. That shows some great practice right there. So throw another 100 points to the chat right there. Take the smaller one and double it. So please understand these relationships right here. Great practice. This last question is worth double points. Is this exam more math and theory, Ryan? Good question right there. A lot like the exams we've been doing, Canvas content, and this review has questions on it that are on the test or are very similar. So definitely check it out. Oh my gosh, this is a crazy thing. You know, we need someone else here because I can't do the last question justice. Only one person can. You know who that is.
It's me, Tiny Brian. Where's my parrot at? Because you all know who I am. I'm Tiny Brian. And there's my pup. That's not my puppet shark. This is my puppet shark. Thank you. Thank you, Tiny Puppet Shark. Where's my parrot? Everyone, Anyone have some study tips? What's up, Lindsay? I'm Tiny Brian. Where's my parrot at? Tiny Brian's parrot. What? Who? No. Tiny Brian's parrot. Come here, you guy. Oh, thank you. You need to get on my shoulder. Oh, thank you. Where you going, little parrot? Come back here. Okay, thank you, guy. Okay. Let's do this. Last question with Tiny Brian. This is where double points. Tiny Brian's publisher compare. Oh, there's Tiny Brian's publisher. Let's do this. Here we go. Tiny Brian's parrot. My shoulder hurts. Let's do this. Last question. Here we go. Okay. Oh my god, double points? What? Brian, Tiny Brian, go to the doctor.
The null is that he doesn't. What is a type 2 error? Tiny parrot, you need to go away. The null is that he does not have scurvy. What is a type 2 error? So the null is that Tiny Brian does not have scurvy. The null is that Tiny Brian does not have scurvy. What is a type 2 error? So in a type 2 error, the null is false. In a type 2 error, the null is false. In a type 2 error, the null is false, but we fail to reject it. So think about that. I just told you the null is false. The null is that he does not have scurvy. That is a false statement. Fail to reject a false null. Jensen, great work right there, Jensen. You are 100% correct. The null is false and we fail to reject it. So think about that means right here. Jensen said it perfectly. We fail to reject a false null. Good work.
Great. Oh my god. What's going on? Here we go.
Okay. So what does this mean? Let's write this out and then let's see the leaderboard. Let's practice. Everyone ready? This is big practice right here. So when we have the null hypothesis, so Tiny Brian has scurvy. Alternative, oh my, does not have scurvy. And the alternative is Tiny Brian has scurvy. Should I have this right? So with this right here, I want you to look at this and I want you to think about a type 1 error. Practice real quick with me. You ready? Type 1 error. Here's your 1. Well, the null is what? I want you to look at this real quick and I want you to look at that null and I want you to say that null is what in a type 1. We're doing type 1 first. In a type 1 error, the null is what? Type 1, the null is this. What am I making right here? The null is true. So it is true that Tiny Brian does not have scurvy in a type 1. But what do we do in a type 1 error? In a type 1 error, the null is true, but what do we do to the null in a type 1 error? In a type 1 error where the null is true, we reject the true null. In a type 1, the null is true. It is true Tiny Brian does not have scurvy, but we reject that and say we have evidence Tiny Brian has scurvy. In the type 2 error, the null is what? Be practicing this right here. I know some people do it. In a type 2, the null is what? Type 2, the null is what? In a type 2, the null is what? You're seeing me, people say, what are you doing? And I say, I am making the following right here. There is what I am making. I am making in a type 2, the null is false. And we do what to the null then? We what it. It is false, and we fail to reject it. That's the second F of the type 2. So it is a false statement that Tiny Brian does not have scurvy. Tiny Brian does have scurvy, because this is a false statement. But we fail to reject the null. So what do? We continue to believe that Tiny Brian does not have scurvy, and sad day.
I got scurvy, guys. Yo, where's my parrot at? He'll make me feel better. Thank you, parrot. Let's find out who won the game. Okay, here we go. Woo, who's gonna win? Parrot, you need to get smaller. Woo! Thank you, parrot. Dynamic cheetah, great job. Fuzzy cat, whoa, you came out of nowhere. Great job. And joyful lemon.
There we go. Great job, everybody. Tiny Brian's parrot, get over here. Great little parrot guy. Good job right there. So great job, everybody. It's got my shoulder. There we go. So great job. Tiny Brian has scurvy, apparently. Oh my gosh, this was insanity. Remember, $50 Amazon gift card to Joyful Lemming. Please email me the email you want it sent to. If you want, who won in the chat? Good luck with finals, everybody. Who won? We'll hang on here for just a moment longer. Great 1 hour Kahoot. I like when we do 1 hour Kahoots. I think that's really excellent. Who won? Joyful Lemming, great job. Did you come in first? Who won? So I'm trying to remember. Great job, Elizabeth. Elizabeth, make sure to email me and email me from your UTK account and then say send it to this email address. Does that make sense, Elizabeth? Just so you know, email me and then I'll send the Amazon gift card and you can, like, I always want people to tell people that I send it to you. Like, yeah, guys, he sent it to me. So people aren't like, you know, great job. Addie, great job right there. $10, Addie. And then who got second? I didn't see who got second. Perfect. And that way, so a random person doesn't email me from like a Yahoo account. It's like, hey, send it to this address. I'd be like, can you email me from your UTK? We'll head here to space. Let's see. Where's my... Is this the right scene right here? Watch this. What's up? Let's head back right here. We're going to go all hacker man right here. Let's do this. So everybody, hang in for a moment. We're just going to answer some questions. We're just going to go back to the future here. Back to our space realm. Let's do this. Let's go from UT here. Woo! This car's not that fast anymore. Let's head over here. Great review, everybody. Great review. Excellent job. Good luck on the exam. Thank you, Elish, right there. Let's put up some Marvel screen. If you have questions, let me know. What questions do people have right now? What questions are there? This is like my favorite song. This is like my get hyped song. My ice cube has like melted this whole exam. This was root beer. Now it's root beer water. Points. Let's throw out some points. Excellent work. Excellent review. 100 points. If you have questions, let me know. I'll hang out for just a few more minutes here, see if there's questions. Good job, Rockstar Tower. Yeah, great job, everybody. Really good review, really good practice. It's repetition that helps. You don't learn this all in one review, and so don't worry, because no one got a perfect score on it, and that's all right. It's a little bit different, and some people, there's hundreds on the exam, but what I found so interesting is first place had 18 right, and second place had 19 points. My best advice. That's a really hard question. 92 is an A. Remember, we have the bonus. Great question right there, Maggie. Make a schedule for yourself. Here's Brian's advice. Did we put a link? It should be links in your thing. I'm always afraid to put links to those in public videos because I'm always afraid of that. Great question right there, Christopher. If you can't find it, email me and I'll send it to you. I'll make sure you have it, Christopher. So I'm always afraid to put like links on public videos and then random people like go and yeah. But if you can't find it, let me know and I'll make sure. Email me. Everyone knows my email address is bstevens@utk.edu. So here's my best advice. Are you ready? This is like serious advice time with Brian. I'm gonna put on the music. Okay. Serious advice time with Brian right here. The best thing I've ever learned in life is to schedule my time. That's the absolute best advice I can give to anybody. And if you don't do well on your exams, it's okay. It's okay. I need to get my transcript and show everyone how many classes I failed. Like, I promise you, I failed a lot of classes. No joke, the last class I took, I failed. I'll tell you why. Because I was taking a PhD class and it was really tough and I was putting in a lot of work and I felt like I wasn't giving enough for my students. And I'm not trying to be sappy, but my students come before my grades. And so I didn't put in the work and I failed the course. And I'm okay with that. I'm okay with that. Like I say, you gotta say it 3 times and then you're really okay with it, right? But it matters more to me that my students are learning and I can have a positive impact there, because I promise you, as much as we think grades matter, and they do, there's things more important than grades. So keep that in mind as you study. Don't burn yourself out. Don't stay up all night every night. Keep track of your mental and physical health. That's super important. But if you do make a D or an F, don't worry, Brian's made a lot of those. Just be like, hey, I'm like Brian. Like, maybe one day I'll end up like Brian. That wouldn't be so bad. I don't think it'd be so bad. I'm me. So don't worry about that. Just put your best effort in. And if your best effort is you have to go to sleep some nights at 8 or 9 p.m. because you're completely tired, do that. If your best effort is you have to go hang out with friends because you just can't take sitting around studying, go do that. Just understand that I think the best advice for all the work you're going to be doing is to create a schedule. Create a schedule, make a plan. Great job, Kyle, right there. Yeah, and that's where the hard work pays off. And if this semester doesn't go the way you want it to, that's okay. Just think about how you can prepare for next semester. Look towards the future, not the past. So if I'm going to give you any advice for life or for this class, Don't look to the past. The past does not define you. It's what you choose to do that defines you. So in any moment, you can choose to just make different choices. Like if this semester didn't go the way you wanted, the next semester be like, okay, now I'm going to try this different thing. I'm going to do this differently. So yeah, it's positivity. It's called locus of control and positivity. And I know it's tough. But just don't worry, because it gets better. Like, I failed a lot of classes. I'm not joking. I'm pretty sure I was in the bottom 50% of my high school. I need to get those transcripts. Next week, encourage Brian. Say, Brian, get your transcripts. Show us that you were in the bottom 50% of your high school. But okay. Are the 2 points on the final grade? That is correct. Caitlin right there. I saw there was a bunch of questions. Do you think exam 3 will get curved? It could be. It could be. We always look at the scores. The average is usually in the low 70s. If something dramatic happens, we do curve it. Don't expect a curve, though. Don't expect a curve. Oh, man. Maybe we should do one. I wish Chelsea was around right now. I'd be like, hey, Chelsea, go grab one of your things. And I'll tell you what. I will try to do man bun next week. We'll have like man bun Brian next week. Sorry right there who said that. I'm trying to see. Kyle, stay tuned next week. We'll try to do man bun Brian. Sometimes I just can't believe how long my hair is getting. That's literally like on my shoulders these days. I don't even think I have long hair. If you ask me, Brian, do you have long hair? I'd be like, no. I'll be like, my hair is medium guy length. This is just medium guy length hair. We'll be doing some review. So, are you talking about the 2 points, Bailey? The 2 points is on your final grade. Yep, because that's how I do all rounding. So please know that any and all rounding on your grade is due to this. You know, Brian sometimes does the night before the exam review, hops in, lets people ask questions. I don't know. I have this, I'm one of those people, you ever like play sports and they say like, don't leave anything on the field? When I ran cross country and you see the finish line, I remember running and feeling like I had cement attached to my legs. Like I remember running up a hill and feeling like my legs just like my muscles just weren't even working. And like I was that tired and I was still just somehow lifting my legs. And that's the way I feel about teaching is sometimes. And maybe I shouldn't have that approach because I don't know. I think people can sometimes tell if I'm a little bit tired or a little bit spacey. But to me, I don't know. I'm one of those people who has a very competitive mindset and I'm very competitive with myself. So I try to like not leave anything on the field for you guys and gals and everyone from New York. But that's what I do. I just like, you don't leave anything on the field. So you give your full effort. That's what I try to do. I'm 80 points away from getting 2 points. Sure, Daniel. Let's do it. Daniel, here's some positivity for you. I was like, I thought you meant like 80 points in the class. I was like, what? Daniel, right there for you. Our averages in Canvas accurate? They should be pretty accurate. The Canvas averages are pretty accurate. Any other questions? You're welcome, Daniel. Thank you for being here, Daniel. Positivity, that's what we're here for. Any other last questions? Anytime. I just want people to have fun, have a good time. It's all about putting in a good effort and drinking water. This is officially water now. Stay tuned, join in the other streams. Wait, Maribeth is super close too. You're right, we need to give Maribeth the points. Maribeth, there you go. Maribeth has reached the level 2. I do agree. I like having fun. It's tough. It's, you know, like, I just remember I can't imagine. My brother is currently doing an MBA and he just talks about how crazy it is because he has, like, school is a big responsibility. And then when you have life, like, for anyone who has life on, like, we all have life. But some people have kids. Some people have job. I was lucky enough when I was in college to not have a job, not have kids. Not lucky to have kids, but responsibility wise, I didn't have things that took up my time and attention. You're welcome, Meredith. Positivity. That's what we're here to do. So yeah, we'll play one more song, then we'll head out. One of our favorite songs right here. But no, I really appreciate it. It's been a great semester. Everyone's worked really hard. And if you, whatever grade you get, if you feel like you worked hard for it, that's awesome. You know, what's funny is the people a lot of times who make like a B sometimes are the happiest, because there'll be someone in this class who makes a B who's like, hey, Brian, I never was good at math. And I like enjoyed coming to class. You know, maybe I made like a C or a D plus on an exam, but I worked hard and I made a B. And then they're like, that just makes my day. I'm like, that's awesome. I'm glad to hear that because, you know, I'd be happy if I made a B in an English class. can't do that. How many years did it take you to finish college? I feel like I've been in college for over 5.5 years? I think it was 5.5 years. I could double check. Pretty sure 5.5 years. I finished in the summer. I finished in the summer of 2005. So yeah, 5.5 years, I believe. I started 2000, finished summer 2005. So I went straight for 5.5 years, and it probably took a total of like 210 credits. Changed majors 3 times. Mathematics. No. Psychology, mathematics, engineering. Did I go 5? I don't know. Something like psychology, mathematics, engineering, mathematics, psychology. That's about what I did. Something like that. So I came to UT as an engineering major, biomechanical or something like that. I don't know. I only did that for a semester. Jensen, so glad to hear that, Jensen. And don't worry, Kyle. I've had friends who took closer to a decade. Not joking. I have friends who... Connor Moore! Happy end of the semester, Connor. Good to see you here, Connor. Thank you, Connor. And actually, Connor, I might be I might need your... I'm doing a forum for supply chain, and we're talking about the importance of data analytics. So, yeah. Yeah, I know changing majors is pretty drastic, especially when I went into engineering and they were like, you're basically starting over. And I'd been going to college for 1.5 years. And I was like, oh, wait, I'm starting over? And then I kind of looked at it and I was like, I don't want to be here for 5.5 years. And then I went for 5.5 years. It's okay. You know, things turned out all right. Went back and did graduate school. You know, things were perfectly fine. Oh, wait. Maybe Connor had a typo. We'll play one more song. It really is just finding what you love and just keep doing that. I mean that. I transferred UT behind on gen eds. Now I'm caught up. It can be done. Exactly. Now I have to take extra classes. Great, Jensen. That's awesome. I do route optimization every day. Exactly. And Connor, I hope you're having a great time right there. We need to talk. Maybe we'll hop on Discord like sometime. We'll just talk because I miss Connor used to swing by my office. We'd bring Red Bull. And I don't know. I think I can drink Red Bull again. What if we get 2.111 instead of 2? You can. Yeah, the points go up to, I'm at the ridiculous tier. I think I'm beyond everyone. I'm in the Brian tier, I think. So the points keep going higher and higher. I'm in Stat Nation Galaxy Brian tier, 2.1111 bonus points. Caitlin is in the Stats Wizard level. So I love it. I think people have had so much fun with these points. So yeah, we call it as New Game Plus. So like Daniel right there, great job. So you're in the New Game Plus. You're in the bonus round. It's right there. You know what? Let's just get this last person up here. We'll end with this. Emma right here. That should be enough to get you to the 3 points. So Emma right there. Thank you so much for all your hard work. That should be enough to get you to the 3-point level. You can check your points again. I'm gonna have a great time, honestly, with the Python web scraping. Script lengths are becoming quite taxing. Oh, wow. They're becoming really long, are they? That's crazy. Yeah. Connor, you're probably a better coder than me these days. Because one of the things you want to do... You're welcome, Emma. Well, thank you for being here. And thank you, everyone, so much for the positivity. One of the things you want to do is you want to... You want to keep practicing. You want to keep going. You know what? I'm just doing it. I don't care. We're ending with the most positive notion ever. There we go. We're getting Zoe there. Okay. I think that does it for everybody. We've gotten everyone who's checking their points up to the max level. I appreciate it. There's always just random opportunities just coming here, hanging out. I know. I don't know. I want some positivity. And you're just coming here. This is it. Help each other. Remember this. Vols help Vols. And I will say this. If you've been in a lot of the classes, there's been a lot of opportunities. Maybe there'll be some more. So if you see me streaming live again, you never know. But please, 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 help each other out. Be positive. And keep helping each other out. I don't know. Same thing again, right? With that, I'll play the nice music here. Stay positive. Help each other out. And Vols help Vols. Vol means all. Bye for now, everyone.